I'm going to try to give you the short version of this, okay? Graphing method. You will realize that we've been doing this already, okay? I'm actually not teaching you anything new. There's maybe just a little twist that I'm going to introduce, okay? We are still doing the same thing here. We're finding the X-intercepts if possible, okay? So nothing has changed. You've got two options here. Option 1, let y equal to 0 if present. Rewrite the equation in general form. Enter left-hand side into y1, right-hand side into y2. Then we use second trace 5 to find all the x-intercepts. This is something we've already been doing. Option 2, I will use a different color for this one. Option 2, we still let y equal to 0 if present, but there's no rewriting necessary. Okay, there's no rewriting necessary with this format. We enter y1 into left-hand side into y1, right-hand side into y2. Second trace 5 to find all the x-intercepts. Since you're finding the x-intercepts, you must state, this is important, this is something you need to take into account, or else you will answer it wrong if you use this method. Okay. So let's go to 22 and let's do this one here using both methods. I'm just going to have my key here because I don't want to get it wrong today. Okay. Let's do the easier option first, what I call option 2. Okay. Basically, you take the left-hand side of this mess, okay? You have terms here, you've got terms there. Sometimes you've got two quadratics. Sometimes you have a quadratic and a linear. It'll be kind of messy, okay? But it doesn't matter. We'll take all this, we'll put this into y1. We'll graph that. And then we'll take this and put this into y2. That is part of your work. So this is your left-hand side. This is your right-hand side of the equal sign. We'll use zoom fit. Zoom fit is really helpful here. May help. Find intersections. Intersection or intersections. Okay. And then use second trace intersect. So let's try this. Grab your calculator. Clear everything that's in your y. Does plot 1 need to be on in this case? We're not using L1 and L2, right? We're not doing a regression. Turn it off. Make sure it's off. So 32x squared minus 15x plus 50. Enter. That's it. Then I go over to this one. I put that into y2 exactly the way I see it. 2 bracket 6x squared plus 125x plus 75. Close the bracket. Now let's try to graph it. What's going on? What do we know about this parabola on this side? Which way is it pointing? A is positive, so we know that this is doing that, right? What's this one? What would A be here on this one? If I go 2 times 6, that'd be 12 positive. This one is also pointing up, right? So just so you know, both of these are pointing up. So what we're going to try to find is, where do these cross each other? That is the important part. So we're going to try zoom, and I'm going to try zoom fit. Zoom fit usually does a pretty good job. Let's see if we can make this work or see most of it. There's one, there's another. So there's the blue one and the red one. It's crossing there, so we can find one intersection already. We need to find the other one, which is over here. Let's chase the curves, okay? So we got to increase what? X max for sure. I'm going to double that. And we also have to increase Y max. So I'm going to go 4,000 for the Y max. So X max 20, Y max 4,000. Let's try that again. Still got to increase my Y max a little bit. Window. Let's go 5,000. Still can't see it. Let's go a little bit more. Y max even bigger. I'm getting tired of this, so I'm going to go 7,500 for the Y max. And there it is. Now I can see both crossings. That is what you want to see. Okay? So you go second, trace, intersect, go closer to the first one, hit enter 3 times. Enter, enter, enter. And there's your coordinate. Write it down. Negative 0.37, 5982. And the other one, second trace 5. Let's go over to it. Enter, enter, enter. That's 1362, 5,779. Okay, hold on to this part, but we're finding X-intercepts, right? Are these X-intercepts? No, right? They're not. So, yeah, go ahead. So one thing you have to do, I did this on purpose, but one thing you have to do is make sure you turn these ones to 0. So when you're about to state, I'm just doing this to emphasize my point, that is one of the X-intercepts, and this is the other X-intercept. We don't really want to copy down the Y values. We are only interested in the X values here. So any quadratic formula that you just did, like the ugly ones where you had to clean up, you could have verified using this method. Type whatever you have on the left into Y1, the right into Y2, figure out these ones, and they should match what you did with your quadratic formula. This is very much connected, okay? This is option 2 that I've just used here. Right next door, we're going to try option 1. Please copy that down for me one more time. It won't get crazier than this, okay? Whatever you see here, go ahead. Whatever you see here is kind of like, in terms of mess that you need to clean up, whatever you've seen in these examples over these couple pages, that's what you can expect, okay? So no curveball on the test. So this is already cleaned up, so I'm going to keep this. But this one, I have to distribute, right? So 2 times 6x squared is 12x squared plus 250x plus 150. So I'm multiplying everything by 2. So you're basically doing the same thing you would do for the quadratic formula. That's why I don't like option 1. Option 1 is more work. There's more room for mistakes. But anyway, so we're going to take this one, bring this over. Take this one, bring it over. Take this one, bring it over. Okay. So it's 32x squared minus 12x squared. And then you've got the minus 15x. You bring this over, minus 250x plus 50. You bring this over, it's minus 150. This is 20x squared minus 265x minus 100 is equal to 0. And now you do the same thing we did over here. You put this into y1, this into y2, second, trace, intersect. Grab your calculators. Clear everything you have on your screens. 20x squared minus 265x minus 100. y2 is equal to 0. Didn't we do this before? Right? Every time I just made you make y2 equal to 0. So this isn't new. You hit graph. There's your curve. We don't even have to change the window. We don't have to adjust anything. Second trace 5. Find this first one. Oh, it's the same, isn't it? Yeah. Negative 3,7. And the second one, second trace 5 again, right? You go over to the other side. Enter, enter, enter. That's 13.620. Boom. Just like the other one. So this is option 1. So I will not make you use one over the other. You choose, but if I say graphing method, you have to do it this way, not using the quadratic formula. Okay? Can I this is just for you. I'll just let you see that this one had something like this, right? Like that. And then we had another one like that. I know this isn't pretty, but you find these two intersections, right? One is y1 and the other one is y2. So I would add this diagram here. This one only shows one graph, right? And you just find these two there. Okay. This is y1, and I guess y2 runs along the I'm going to use a highlighter for this. y2 goes along the x-axis here, right? But both do the same thing. You should be able to plug this into your quadratic formula equation and get the same answers, right? It should all jive. Everything should be the same. So I want you to practice this because your window is going to be the problem here, finding a window that works for you. So I'm going to say page 23 to, I'm going to say you do as much as you like, but I'm going to say 23 to 24 does a pretty good job, and then you're good.